Hi, you're listening to Stephan Livera podcast, a show about Bitcoin and Austrian economics brought to you by Swan Bitcoin. Today, Robin from the ZeroSync project joins me to talk about ZKPs, Zero Knowledge Proofs, and how they can be used to help people quickly get started using Bitcoin. And in this case, ZeroSync helps people dramatically speed up IBD, initial block download. So what does this mean? It could mean more people could run Bitcoin nodes. It might also help more people be private and verify things for themselves. So we talk a bit about the trade-offs around this and what's required to make it happen. Mempool.space is one of the sponsors of this show, and if you need to send an on-chain Bitcoin transaction, I recommend first checking Mempool.space so that you can check the fee rate. Now, of course, Mempool.space is open source and you can host it yourself, and it makes it really easy to see the multi-layer ecosystem that Bitcoin is evolving into. You can see different things such as the mempool, the blockchain, or the Lightning Network. Mempool.space are also coming out soon with a transaction accelerator service, so keep an eye out for more details on this product. And if you are with an enterprise, Mempool.space also offers customized mempool instances with your company's branding, increased API limits, and more. Go and find out more at mempool.space/enterprise. When it comes to securing your Bitcoin, consider the hardware that you are using to hold your private keys and also to sign Bitcoin transactions. CoinKite.com make it easy for you to do this with a range of hardware devices such as the Tap Signer, the latest Cold Card Mark IV, and the upcoming Cold Card Q1, which will have QR support. With the Cold Card, it has two secure elements, it's got NFC support, and it's really fast at signing transactions, and it's also very reliable. Also, I really like that you can set it up without phoning home to the manufacturer. You can literally just plug it into the wall and generate your keys. That way, you can even bring your own entropy. So if you don't want to trust and you want to verify, you can bring your own entropy, whether that is through using dice rolls or entering your own seed, and you can initialize the device in that way. And then you can connect it with wallets such as Spectre Desktop or Sparrow, Nunchuck, or Electrum. So to get your cold card, go to coinkite.com, use code Livera for a discount on your cold cards. And the lead sponsor of this show is Swan.com. Swan Bitcoin make it easy for you to buy Bitcoin in a safe and easy way. Of course, Bitcoin can be volatile, but with Swan Bitcoin, there is a range of educational material that makes it easy for you to learn about Bitcoin at the same time as stacking. So it's easy to automatically stack some Bitcoin and automatically withdraw to your own self-custody, because with Swan, automated withdrawals are free. So with Swan, you can do automated recurring purchase, and also you can do what's called smash buys or one-time buys. Swan makes it really easy for you to do all of this stuff, so go and check it out over at swan.com. And now onto the show with Robin. Robin, welcome to the show.
Thanks a lot for having me. Very excited.
Yeah, so Robin, I was intrigued by some of what you're working on and what you were speaking about as well at the Bitcoin conference. Obviously, we met backstage there, and I was intrigued by this idea of what you're working on with ZeroSync, and maybe you want to just help set the stage a little bit, and perhaps set some of the context about what is a ZKP, and what is some of this stuff that you're working on.
ZKP is a bit of a confusing term. It's called Zero Knowledge Proof. Zero Knowledge Proofs have originally been invented for privacy, but they have kind of been rediscovered as a great tool for compression. And those buzzwords that you hear all the time in the altcoin sphere, like ZK rollups and such, they are usually using validity proofs and not zero knowledge proofs. And they're using them to compress lots of transactions into a very succinct proof. And we are spearheading the application of validity proofs to Bitcoin.
Gotcha. And so I guess at a high level, maybe just to understand, is it similar to this idea that, when you do a hash function, it's deterministic? Or if you're using a deterministic hash function, the same, input value will always hash to the same, shortened hash output. And that's kind of what we're relying on here, so that we can, as you said, use it as a validity proof to sort of prove that, the content of these blocks, of these transactions, etc., maps to this particular output. Is that kind of the high level idea here?
It's related, but when you hash something, you don't actually know anything about the validity of what you're hashing. Like when I give you a block hash, it doesn't tell you anything about the validity of the block. And here you actually get a proof of the validity of the block. And that is quite big because you can instantly verify lots of computation with just that little proof. It's actually a proof, which means even if your biggest enemy had created that proof, they cannot fool you even the slightest bit.
Gotcha. So that's an important point to understand because of the trust levels that we're talking about here, right? As you said, you don't have to trust the ZKP proof provider. It is literally a proof. You are able to verify that.
Yes, exactly, yes.
Gotcha.
I mean, there can always be problems in the implementation and stuff, but in general, the concept is actually a proof, a mathematical proof.
I see. Gotcha. And so do you want to just tell us a little bit about how this could be used in Bitcoin and just outline a little bit of the high-level basics for us?
Yeah, there's a range of applications to Bitcoin. The first or most obvious application is to compress the Bitcoin blockchain. So currently it's 500 gigabytes, and with a validity proof, you can compress it in less than a megabyte. And that would make it much faster to bootstrap a full node.
Gotcha. And so so I think that's really the bottom line is that we could dramatically speed up how quickly it is for a new person to onboard a new node when they're starting up. Because today, you have to, if you sit there and you're downloading all the blocks from Genesis, you are downloading over 500 gigabytes, depending on the size of your computer and your internet speed. It could take a while, right? Especially if you're on an old Raspberry Pi and it takes a long time to download and validate and all of this stuff. Maybe if you're on, let's say, a reasonably fast desktop computer with a high-speed internet connection, maybe it's a few hours. But even then, that's a desktop computer and it has to be on all the time.
Exactly.
So I guess that's kind of what we're getting at. And I've seen, I guess I would say there are two different uses. Maybe it would be useful for you to spell this out also, because in altcoin land, there are people who are using it to, let's say, compress transactions, or they're trying to use it almost like a lightning network sort of thing to kind of speed up the transactions. But what we're talking about in this case with ZeroSync is not that. What we're talking about here is the initial block download, just so listeners are clear, right?
Exactly, yeah. We are building a validity proof of the Bitcoin blockchain itself, not a layer 2 on top of the main layer, but the main layer itself.
Gotcha. And so some of this stuff can get confusing because sometimes people talk about soft forks in the context of having a ZKP verifier for Bitcoin. So to be clear, for this project, for ZeroSync, relating to the IBD, the initial block download, is a soft fork required for this? No soft fork is required. We are just compressing the chain, and we can just compress the chain without asking anyone. And it's an individual decision. Every user can decide if they want to sync using a conventional sync or if they want to use a proof. So gotcha.
That fits very neatly.
Gotcha. Yeah. And so can you walk us through how this would work to help people speed up their IBD using, the ZeroSync proof?
Mm-hmm. You would download the proof from somewhere. I will come to that later, where you would download that exactly. But you would download that proof. And in that proof, there is a UTXO set commitment. Then you would also download the UTXO set and match it against the commitment in the proof. And then you can be certain that this UTXO set is actually correct. So you just copy it into your chain state folder and run Bitcoin Core as you're used to as a pruned full node.
I see. And so, and even some of those aspects that you were talking about, copying to your chain state folder and things like this could be automated as well, right? Like software developers could come up with, a wallet that automatically does all this in the background, just to be clear. I guess you're just explaining sort of for the developers and the more power users, what's actually happening in the background.
Yeah, exactly. It could be a simple patch to Bitcoin Core or even an external tool like a simple Python tool or something like that.
Yeah, I see. And so just to explain also what we're talking about there is, today when you download Bitcoin Core and if you just run it by default, it's going to download all the headers, all the blocks, and it will verify from, there's like an assume valid point, I think, I don't know exactly, it might be 6 months or 12 months back, and the node is going to verify all the signatures from that point forward. Now, if you turn that flag off manually, it's going to verify from day one, Genesis block. But in this model, it's different to that. Instead of downloading all the blocks, all 500 gig of the blocks, we are instead downloading a proof of the UTXO set, which is like 5 gigs or 10 gigs roughly, right? Yeah. And so then the user is able to just quickly onboard and start transacting or receiving coins, because he can generate an address and receive coins and do all this stuff very quickly, because he doesn't have to download that 500 gigs. He's just downloading an equivalent of the UTXO state.
Yes.
And proving it. That's correct, right?
Yeah. And verifying the UTXO set is much cheaper. Like 5 gigabyte of UTXO set is just a bit of hashing. And when you have 5 gigabyte of blocks in comparison, you have to verify all the signatures in there, which is usually the bottleneck. So it becomes way cheaper. Like it's less data and less verification on that data.
Excellent. And so in your view, who is the target market? Who is the target user? Are we talking like mobile phone users here? Are we talking just what would have otherwise been a light client, let's say Electrum or Sparrow or Spectre user? Who is the target user for this kind of ZeroSync protocol?
I would think that in the future, like in the next decade or so, basically all Bitcoin apps will become fully validating with some kind of proof system, I would say. Like I would expect that. Just because proof systems are growing so fast and it's getting more and more easy to actually do something like we are doing and proving the Bitcoin blockchain. So I think at one point, mostly every Bitcoin app will be fully validating by using a proof. There will always be still some conventional nodes, I think, because the more high value use cases, the more incentive you have to just go through the initial 8 hours of syncing or so. But it would be great to have every phone being a validating node, a fully validating node.
And so can you explain for us that difference in the different types of nodes then? So as an example, we have the archival node, we have a full node, and then we have, let's say, a ZeroSync node, and then maybe there's just like light client. So can you just explain the difference in those?
Yeah, so there would be conventional nodes, conventional archiving nodes. Also, they would, in the future, they would also provide the UTXO set. So they would make a checkpoint maybe 4 times a day or something. And then when others want to sync, they get this checkpointed UTXO set from them. And then you would still have pruned full nodes that have been synced with a proof. And also that is not our first goal, but in the future we would want to support light clients as well. That requires to make the UTXO set a bit more like the Ethereum tree, because when you're a light client, you want to approve all UTXOs of a particular address. Like you ask a server for your balance, and you don't want them to withhold any of your UTXOs. So the server has to prove to you that this set of UTXOs is actually all the UTXOs that you own, and
right,
none of them
it's
are
complete.
Missing.
It's checking completeness.
Yeah, that's complete, exactly. And for that, we would have to adjust our UTXO set commitment a bit. Currently, we are using UTXO, and UTXO cannot prove completeness.
I see. Okay,
and so that is definitely doable.
Right, and so let's just summarize those different things so people are clear. So archival node means your node has downloaded all of Bitcoin's blocks and retains all of those blocks, and it has them in memory or in the hard drive somewhere, so it can call them as it needs, right? So that's kind of I guess we can call that the best level, let's say. Then the next level is a full node that once had all the blocks, but has now pruned away the old ones. So that would be a pruned full node, because it is still a full node because you verified all the blocks. And then let's say another step is to have a ZeroSync node, right? So this node never downloaded all the blocks. It just quickly caught up to the state based on this commitment, this ZKP proof, this and verified in that way, and then just caught up from that point and just was downloading the new blocks on, from that point on in an ongoing fashion. So is that basically, you would say that's a fair summary of, let's say, some of the types of nodes that we're talking about here?
Yes. You can have different other things. For example, you could sync with a proof and then use assume UTXO. That means you give a UTXO set to your node and it assumes that it's correct, but in the background it does the conventional sync and proves that the UTXO set is actually correct. So this way you could instantly sync, but have the conventional full node security as well.
I see. So it's like you quickly get caught up, but actually in the background, your node is running the checks as well to sort of kind of make sure it's all legit, basically. And actually, that would be a good point to help if you could distinguish the difference in these different projects, because maybe some listeners will be a bit confused or maybe not see exactly where the lines of demarcation are. So if you could explain the difference, let's say we've got utreexo, which is sort of similar, sort of related. There's assumeutxo, which you just mentioned, and there's ZeroSync. So could you just explain the difference in those three?
I would say the main point of utreexo is to compress the UTXO set, because the more users Bitcoin has, the more the UTXO set grows. And if we had 1 billion users, then we would have to have at least 1 billion UTXOs, and having that in memory is probably not possible for most consumer devices. And that's why the inventors of UTXO came up with that idea of using a UTXO set commitment that is constant size. And then you only need inclusion proofs for the UTXOs that have been consumed in the latest block. And that reduces the overhead of the UTXO set from multiple gigabytes down to kilobytes or something. And the problem with it in comparison to ZK nodes is that utreexo nodes still have to do the initial sync. They still have to download the entire blockchain once. And it's even a bit more overhead, because when you're running that utreexo node, you need to have those inclusion proofs attached to every block, UTXO inclusion proofs. And I think they made it quite fast, but still you have to do the initial download. And that's why it's a nice it can be nicely combined with a proof, because our proof, it would allow you to run a UTXO node basically instantly, because you can catch up to the latest state with the proof, and then from then on you listen for UTXO blocks.
I see. And so to be clear then, in a ZeroSync example, you would download, let's say, 5 gigs worth of the UTXO set, a few megs of the proof, and then you're basically caught up?
But when you're running a utreexo node, you would not even have to download the UTXO set.
Oh, I see. So you're talking about like a combination of the ideas, right? If you did utreexo and ZeroSync, you could sort of run them together in parallel, let's say. Now, this would be...
first the proof and then the utreexo node. Because the UTXO node is great to stay in sync, but our proof is awesome to
get the IBD done quickly. Yeah, I see.
Exactly.
And then now contrasting that with assumeutxo, which is another idea from James OB, and I know he's trying to push that forward as well. Could you contrast that idea?
It is similar, since it allows you to start your node instantly. You give it a UTXO set, and then it assumes that this UTXO set is valid and starts listening for new blocks instantly. But it cannot verify the UTXO set instantly. It has to do the entire catch-up to be certain at the end that it was actually the correct UTXO set. And this can be greatly combined with our proof as well, because you can proof a UTXO set, then give it to the Bitcoin Core node via the assume UTXO option, and then you can instantly run your node and also catch up in the background to be absolutely certain that it was actually correct. And even if there is a bug in our proof, then you would catch it with this approach.
Interesting. And so we can view this like a scaling technique and maybe a verifying technique to help people quickly onboard, and maybe it might help users use Bitcoin in a less trusting way or a non-trusting way compared to today, where a lot of users are basically in a custodial situation, or maybe they are self-custodying, but they are using a light client that calls out to, let's say, a public Electrum server. Let's say they're using Sparrow or something like this, and it calls out to a public server, then they're doxing their privacy. So I guess you could also argue this might help privacy too.
Definitely, yes, yeah.
Okay.
And there are lots of ways to make those light clients more efficient and also more privacy preserving. And I think that would be great in particular for mobile users. And in general, like there are about 50,000 full nodes, but there are estimated to be millions of Bitcoin users. So there's a huge asymmetry and there's a huge room for improvement for more people.
Because we have to ask the question, why aren't those users using a full node, right? And maybe for some of them, they don't know that they should be doing that. Maybe for some of them, it's a monetary cost, or it's too technically difficult. Maybe the software is not easy and the user experience is not easy for them to just download and use Bitcoin Core. They want the features that some other product has. So there's probably a range of reasons for that. But hopefully, ZeroSync might be part of an answer there to help them step up their sovereignty, let's say. So from your presentation, I've seen you spoke about, I think one of your slides talked about the different levels of what can be verified. So for example, you said there's headers chain, there's a quote unquote assume valid, which is an existing setting in Bitcoin today. And then there's also the full chain state proof. Can you just outline what's going on there? And is it right to say ZeroSync would be a full chain state proof?
Yes, we are building the full chain state proof in 3 stages. The first stage is the headers chain proof, which is very similar to an SPV client. It's the most simple proof, but that's the best way for us to get started. And the most interesting bit about that is that we are already augmenting the chain with a new data structure. We are building a headers chain. We are building a Merkle tree over the headers. So you can easily, you can use that for succinct proofs of inclusion for basically every block or every transaction at the end. And that is already quite cool because people have been talking about such things for quite a while, but it's hard to find consensus on them. But when you implement it in a proof, you get it in a trustless manner and it requires no activation drama whatsoever. It's just works instantly. And if you don't like our Merkle tree, if you want some kind of other Merkle tree, you can just build your own Merkle tree. The second stage is what we call the assume valid proof. Assume valid because there is an option in Bitcoin Core that allows you to assume that the scripts are valid until a certain block. And that is basically what our proof does. It verifies everything except for the script data. So it does already verify the UTXO set, the inputs and outputs, the fees, the coin emission schedule, and basically every Bitcoin rule except for the script validation. And the third stage would be the full chain state proof that verifies everything the other 2 proofs are verifying, including the script validation.
I see. And so you're building that up in progression so that there's steps there, and then over time your proof will cover more things, or it'll prove more things.
Yes.
So the idea is the user can benefit from that verification that's being done. And so as I understand, it's like you are centrally computing that proof, and you're going to, maybe there might be clients who download that proof and they can use that proof. Is that the right understanding here, or how do you see it?
Kinda. It is an issue to prove the existing 800,000 blocks or what we have, and doing that. We will do that probably with specialized hardware. We're talking to people like it's becoming a big thing that hardware builders they are building ASICs and FPGAs for proof systems, and we will probably use something like that for the initial catch up. But once we have proven the chain, we just share that proof, and then everybody else can extend that chain proof with the next block as soon as it arrives. We don't want to become the central prover that provides the proof for everyone. We want it to decentralize as much as possible. And other projects are already they have already solved this problem of how do you prove a block in a distributed manner, and we will basically just copy that and
Gotcha. And so just to be clear for listeners, ZeroSync, is it a business? Is it a project? Can you just explain what's the structure of this and how would it be sustainable going forward as well?
Yeah, we've founded a Swiss nonprofit, and our hypothesis is that this is very valuable to the entire Bitcoin ecosystem. We think that's very valuable infrastructure, and if that is the case, then probably there will be people who want to fund it. And if not, we should probably work on something else. But right now, it looks good, and people are interested in it. And it looks like at least for the next year, we will find funding and see how far we can get and what we can deliver in that time.
Great. And so maybe the case will be there might be some wallet providers who say, hey, this is the infrastructure we're going to use. Let's chip in some money. Yeah. Maybe that's the way it could go. And so the wallet, they might have their own business model. I mean, who knows? And so also, that reminds me, I know Blockstream has been looking at implementing this into Blockstream Satellite. So could you explain a little bit about how that's going to work?
Yeah, Blockstream Satellite is very exciting because it allows you to sync the Bitcoin blockchain from basically anywhere on Earth. As long as you have a satellite dish, you can use their satellite to sync the blockchain. The main problem here is that it's very bandwidth constrained. Currently, syncing from scratch takes maybe a month or so, definitely multiple weeks. And that setting is obviously a great match for our chain state proof because in particular in combination with a UTXO node, you could just download the chain state proof and then run the UTXO node, and you could instantly sync via the Blockstream satellites.
I see. And so in that far-flung future, or maybe not so far-flung future, but let's say users find ways to use this, and maybe there's wallet software and things that have a nice UX. So basically that user can download an app on his phone, and it will quickly kind of sync up to what the current state of the blockchain is. It will quickly be able to sync up with what's the state of the UTXO set. And so he can just kind of really quickly onboard and start, receiving and spending in a non-custodial way, self-custodial way, while doing some form of verification, even if it's not downloading the blocks and verifying themselves.
Yes, exactly.
Got it. And so could you also explain a little bit about how it would work if you do this and then let's say your node goes offline and now you need to catch up again? So would it be sort of like you use ZeroSync again, or is it more like you could, just for the sake of example, let's say I use ZeroSync right now today, and then I turn the computer off, I turn it back on in 1 week's time. My computer just needs to download 1 week's worth of blocks, or is there another way that I could just ZeroSync again?
In the most simple way, you would just resync, you would just sync the last week of blocks. But when we make that UTXO set commitment more sophisticated, then it would be possible to just download the delta of the UTXO set commitment. That I see. Download what's new.
So I could actually download the difference and then just...
Yes, exactly.
Yeah. Oh, very clever. Okay, so then that might be more useful. Let's say my computer's been offline for 3 months. So it's like some laptop sitting there. I haven't used it. Maybe it's like my cold storage. I don't really use it that often. But now I could turn it on, and in that hypothetical future, it could sync up that difference, and then I could just be running in a verifying way or in a validating way. So I guess what's the implication then if more clients become fully verifying? I mean, what do you see that doing for the ecosystem?
Yeah, on the one hand, I would say the entire system becomes more decentralized because the entire security relies on basically every user verifying every transaction. And that scales poorly in the plain setting, but using a proof that would actually scale. And so I think that is a great advantage. But on the other hand, there's also the problem of the data availability problem, because our proof can verify mostly all consensus rules, but it cannot verify data availability. By design, it's not downloading the blocks, so it doesn't know if the blocks are actually available or not. And there are some concerns that this might become a problem at some point. I think it's not that big of an issue, because as long as they are honest full nodes, they will never go into a state for which they don't have the block. And when they have the block, they will keep sharing the block. And as long as there's at least one honest node that is sharing the blocks, then there is no data availability problem. Also, there are a few mitigations. For example, when you sync, you could do it such that you don't sync to the latest tip. You just sync to like 100 blocks back, and then you download the latest 100 blocks. And then you have verified that at least the latest 100 blocks exist. And that mitigates most of the attacks that people can think of, what you could actually do by withholding some blocks. And the other thing is that all kinds of network split attacks, well, I should explain that there is actually an issue with those network split attacks, because let's assume there is a future where we succeeded in building everything and it works all great. Then it would be likely that we have some scenario that is like we have still 50,000 conventional nodes. And then on the other hand, there's like, let's say, tens of millions ZK nodes, because everybody is running a ZK node on their phone. So that could be like orders of magnitudes how things could work out. And then you could try to trick the ZK nodes into believing into a block state or into a chain state that the others don't believe in, because they don't have the block for it. But making the other nodes believe in a chain state for which the others don't have the block requires you to mine that block. You cannot make them believe in any block. That is not possible. You can only make them believe in valid blocks. So you do have to mine those blocks to make the ZK nodes believe in it. And that is basically a 51% attack. So it all boils down to the 51% attack. And if you can do that, then you can probably do more harm, and you don't really need our proofs for it or not. So
I see. Yeah, I think that's an interesting way to put it. And so essentially, you're relying on the same checks that normal Bitcoin nodes do anyway. And what you in that scenario, you would see people fall out of sync, and so people might send a transaction and be like, "Wait a sec, I don't see that transaction. Where what's going on?" And then at that point, people will be like, "Hang on, hey, something's up here. We need to check something." And hopefully, there'd be enough, let's say, normal non-ZK nodes in the future, and of course, there'll be kind of a hardcore community of people who are just running them anyway because they don't want to do any ZK stuff. They just want to do the normal, fully archival node, let's say. And so, yeah, that's an interesting one. Also, there is an interesting caveat with all this, and you pointed this out in the talk, but if you could elaborate a bit, you said the longest chain rule must be verified on the node level. So can you just elaborate on that and explain that caveat?
Yeah. That's pretty much more a caveat. It's not a fundamental problem. I just pointed it out because in an earlier talk, I confused someone and they got really mad at me for saying that it would prove all consensus rules, even though it cannot verify the longest chain rule. The longest chain rule means if I have two peers telling me conflicting story, peer one believes in chain A and peer two believes in chain B, then I have to figure out which is the longest chain, which chain contains the most work. And the same thing has to be done with a proof, because a proof is only aware of a single chain at a time. Like you cannot provably connect it to a peer-to-peer network. That just doesn't work. So you can only prove a single chain. But as long as you are connected to a peer-to-peer network where you have at least at least one honest peer, then you can receive a chain state proof for the state that they believe in, and you can receive a chain state proof for what other peers believe in, and then you can you can instantly compare it and see first which one is the correct chain, or are both chains actually valid, and the second one is which one is the longest chain. And a proof makes it much easier to verify that.
Okay, gotcha. Yeah, so it comes down to a very long-standing rule: heaviest chain or most accumulated proof of work on the valid chain. I think that's reasonably well understood. And so, in terms of ZeroSync, the project, what's required to sort of see this brought to life, or what's required at this point? Where are you guys at today, and what does it take?
Yeah, we started a year ago. We got an initial research grant from Geometry Research, and that helped us to build a first prototype. And that first prototype, as I said, is doing this assume valid proof, validating most of the consensus rules except for the script validation. And that works as a prototype. However, it's still horribly slow. Proving a single block, or like proving a full block, takes about 4 hours currently. And 4 hours is, of course, way too long. We have to get it down to 10 minutes. Of course, throwing hardware at it helps to some degree, but there are lots of other optimizations that we can do. There's a list of simple optimizations that we can do and a list of more complex optimizations, most notably parallelization, so that people can prove in parallel. So we would chunk up the blocks into small chunks of transactions, let's say 10, 20, 30 transactions, something. And then person A gets the first chunk, person B gets the second chunk, and so on. And then we aggregate that into one block proof. And this will give us a speed up of probably 100x or something. And also makes it possible to do the proving on consumer hardware. Currently, we have a very beefy server to do it, and it's still too slow.
Yeah. And actually, can you explain a little bit about that idea that instead of just having one centralized proving institution or server, this idea that you might try to distribute it? Could you explain how that would work?
Yeah. In the naive setting, it's quite complicated because you have to have the entire block verification in a single proof. And this takes about 100 gigabyte of RAM or so, which most people just don't have. And but we can chunk it up. As I said, we take the 1,000 blocks or so and chunk them up into did I say blocks? 1,000 transactions, and then we chunk them up in chunks of like 30 or so, and then they get distributed to everybody who connects to the network, to the proving network, and then they can prove chunks of it, and then they send it to aggregators, and then aggregators just keep recursing on those proofs. And maybe I should introduce the idea of proof recursion. Proof recursion means I verify a proof in a proof. And I have if I have two proofs, and I can verify them both in the same proof, and then I get like a Merkle-like structure of proofs. And this way you can aggregate lots of batches into more layers until you have a single root proving all the transactions contained in a block.
I'm curious then, is that relying on some sense of altruism by people to be part of that distributed prover or solver network, right? There's not really a monetary incentive for that, but maybe you would depends, there might be some more hardcore users out there who, let's say, want to contribute. But basically the question is it relying on altruism?
Yes.
Or quote unquote altruism, let's say.
There might be some ways to monetize it, but we think that it might also work out for just altruism. If there's 100 people worldwide who are willing to run a regular computer at home, that would suffice.
I see. And so would these 100 people have to be running it continuously, or is it's like a continuous proving thing, right?
Yeah, it depends on the frequency, how many proofs you want to have. If you want to have a proof every 10 minutes, then you need someone to prove it every 10 minutes. But you could gain some advantage, like some performance advantage, if you batch proving. Like if you prove only like batches of like, let's say 150 blocks or something, then that could be a bit more performant than proving every block by itself.
I see. So the way is you might have some interval, and like you said, it might be like on every 150 blocks, and then so the users, they can just ZeroSync up to that and then download manually the last 100 blocks or whatever to catch up to the latest, to the chain tip, as it's called, to the latest block, and that's just kind of the way it works. And depending on how many computing resources you have who are contributing, you can sort of set that time interval to something that makes sense, right? Whether it's download this and you have to download the last few hours or maybe the last day of blocks, something like that. Maybe it's a little bit more feasible. Although that said, for mobile clients, it probably needs to be relatively close to the chain tip, just because of download capacity, and maybe people are in places with bad connection or not a lot of data on their plan, so they can't just download gigabytes and gigabytes. But how are you sort of seeing that? You would just try to find a happy medium compromise there?
Yeah, exactly. And I think the more popular it gets, the more people will be altruistic and contribute computational resources to the proving. And on the other hand, it will get cheaper over time. We can probably expect that the cost of proving drops exponentially, just like everything, like all costs of
just
computation.
Like Moore's law stuff. Yeah. Gotcha. And I mean, you could sort of view it like a Bitcoin version of SETI at home, right? Like if people remember that there was like this OG, it's not OG, maybe like 15, 20 years old. There was like this computer program that people were using, and they sort of felt like they were chipping into the search for extraterrestrial life. It was kind of a similar, maybe you have a similar kind of program like that people can download and run it on their computer and contribute, let's say, computing power to the prover, to the proof machine, let's say.
Exactly, yeah. There are a few others that are similar, like finding twin primes or something.
Right. I think there's some protein folding thing. I don't know exactly. Something like that.
And I feel like these things show that it is feasible in practice, that people are altruistic enough to do these kinds of computation just pro bono.
Gotcha. Yeah. And let's talk a little bit about the longer term. This is one other idea I saw you mention, and we spoke about it, I think, while we were backstage. You mentioned this idea of compute indexes or filters, and that this could be used for, let's say, Lightning or other layer 2 things. Can you explain a little bit about what that idea is and just elaborate on that?
Mm-hmm. Yeah. The chain proof can be turned into a chain processing proof, that it can process the chain, and you can give it basically any kind of function that it should check the chain data for, and then it can just do that in a provable way. It might sound a bit abstract, but a concrete example would be, for example, for Lightning nodes. If the proof proves to them the unilateral channel closes of all of the last 2 weeks, for example, this way they would not have to download the entire chain. They just download the proof and exactly the data that they are looking for in the chain, because that is what a Lightning node does. It scans the block for unilateral channel closes, and then it looks if one of those unilateral channel closes was one of their own channels. And with a chain processing proof, you can just filter the chain for exactly that data. And you can have arbitrary filters, whatever suits you. You can basically build a custom proof for it and then process the chain using that custom proof. Like more, you would use our chain state proof, and then on top of that, you would have an adapter that allows you to add any kind of computation to it. And this can be interesting for all kinds of protocols that are built on top of Bitcoin. Another interesting application is domain name systems. Most things about domain name systems are actually easy. You can just represent them as an NFT on Bitcoin, and then you can send them around, and you can buy them for Bitcoins and sell them and stuff. But a few things are complicated. For example, if you register a domain, then you want to be certain that nobody else registered it before. So you kind of have to prove that nobody registered it. And that is complicated if you don't process the entire chain. But with a chain state proof, or with a chain processing proof, you could just scan the chain for all registrations of domains, and then create like some kind of Merkle tree, maybe a Merkle Patricia tree or something, that creates a commitment, something like a UTXO set commitment over all domains. And that would make domain name systems on top of Bitcoin much more efficient than the current designs.
I see. So essentially, it can act like a special kind of filter, and users could do kind of like a query. Let's say they could be a Lightning user, and they could query the ZeroSync prover to say, hey, can you show me any Lightning channel closes, because I need to know if I need to do a justice transaction because somebody's trying to cheat me or whatever. Show me for the last 1 week. And it will kind of feed you a filter that tells you what the information that's relevant for you on whether you had any of your channels unilaterally close on the other party. The other party tried to close it, and now you need to know whether you need to do your justice transaction or your penalty close transaction, as an example. And maybe in the future, there'll be other L2 implications or things that might be useful to use this kind of filter for, whether it's, Lightning or Arc or DLCs. Maybe DLCs, like there's a bet and you want to see, has there been a contract close action on the chain, as an example, something like this.
Yeah, exactly that.
Yeah. Okay. So I think those are most of the key questions. So let me just, again, we've been through a lot of technical stuff, kind of like we did with the episode recently. Let me just try and summarize kind of high level for the layman how I see it, and you tell me if I'm getting it wrong, if you want to elaborate. So basically what we're talking about here is a way to, ZeroSync is this way for clients, users, to quickly download and prove the current or a recent UTXO set of Bitcoin, meaning they can quickly catch up and quickly start transacting in a validating way, where currently many of those users are custodial or light client users. Now they would actually be verifying, at least using a zero knowledge proof to verify, even if they're not able to do it the traditional way. And so the implication of this means we could have a lot more users who are verifying, and you could argue it's going to help the network become more robust in a way, because more people are verifying, there's less people trusting. You could also argue that it's more private for those users, because now they're not asking a public Electrum server or some centralized wallet server to feed them their balance and their transactions. They're able to check it themselves using this ZeroSync protocol. And it's also, as you mentioned earlier, possible to be combined with other ideas such as utreexo, which means you could both quickly download and catch up in a really fast way to get up and running, even on a mobile phone, as an example. The downside, as you mentioned, is that there are certain caveats that you have to verify the longest chain rule at the node level. So you need there to be enough honest nodes. But I think that's probably a safe enough assumption. If you're using Bitcoin and you're bullish on Bitcoin, I think you're probably going to assume that to be true. And it's a project that is, looking for funding, looking for supporters. What do you think? Was it a fair summary, or anything else you want to add there?
Yeah, you nailed it. That's exactly it, yes.
Okay, fantastic. So look, for any listeners who want to support you or find out more, what's the best place for them to find you guys and learn more or support you guys?
On zerosync.org. That's our homepage. There you can find all kinds of information, our paper that we wrote about our prototype. And also, you can find contacts. Our Telegram channel, Twitter, GitHub, all these channels.
Fantastic. Well, all the links will be in the show notes. And Robin, thank you for joining me and explaining. I think it's an exciting idea, and it might be, we say in Bitcoin, don't trust, verify. This might be something that helps more people actually do that. So thanks for your work, and thanks for joining me today.
Yeah, thanks a lot for having me.
Show notes are available at stephanlivera.com. Make sure to share the show so more people can learn about Bitcoin. Thanks for listening, and I'll see you in the Citadels.